Picture the largest toothed predator on Earth, 3 times as long as a school bus, diving deeper than the Empire State Building is tall, hunting in total darkness. Now picture 5 black and white killer whales circling it, ready to attack. The math favors the killer whales. It should be over in minutes. Sperm whales have found ways to survive, confuse, and even repel the ocean's most feared hunters. Ahead, you will watch a pod bunch into a living fortress. You will see a wall of tails aimed at a killer whale's face. You will witness sperm whales unleash a weapon built from their own bodies. One so strange it stunned the scientists who filmed it. If stories like this pull you in, tap like and subscribe. It helps this channel keep making them. Take a breath. The ocean's deadliest standoff is about to begin. 3 fishermen are trailing a line behind their boat watching for sardines, 30 miles from the coast of Honduras. The water ahead looks wrong. Something is churning below the surface, throwing up spray, and a shape rolls into view that is far too big to be a dolphin. A black fin cuts through water stained red, then another. The men cut the engine and drift closer, phones out, hearts pounding. What they are looking at is not a school of fish or a feeding frenzy. It is killer whales, an adult male and a mother with her calf, working together to bring down a sperm whale. The attack has clearly been going on for a while. The water around the boat carries streaks of red, thinning and spreading with every wave. The sperm whale, still alive, is smaller than most of its kind, likely a young one caught away from the safety of its group. The orcas take turns. One holds position near the head, another circles wide, waiting for an opening. The third slams into the whale's side with the full weight of its body. For minutes, nobody on the boat speaks. Killer whale attacks on dolphins and seals happen often enough to be filmed for nature documentaries every year. An attack on a sperm whale is something else entirely. Scientists who later studied the footage would call it one of the only sightings of its kind confirmed in that stretch of ocean, a part of the Caribbean rarely explored by researchers. The fishermen had wandered by accident into one of the rarest hunts in the sea. Before the sighting, only a small handful of attacks on sperm whales had ever been confirmed with clear photographs or video, scattered across decades of ocean research. Most earlier reports came secondhand, from sailors describing something they glimpsed for only a few seconds before it vanished beneath the waves. Here is the part that should stop you in your tracks. Sperm whales are not easy prey. An adult can crush a giant squid with jaws built for the deepest, darkest water on Earth. They can dive over a mile down and survive pressure that would crumple a submarine. And yet here, in open water off a quiet island, 3 killer whales had decided the risk was worth it. Why would anything, even a killer whale, choose to fight an animal built like that? The answer is not simple courage, it is planning. Killer whales do not charge in blindly. They study, they wait, and they strike in a pattern built over generations. This particular family had likely learned pieces of this exact strategy from whales that came before them, passed down, the way a recipe moved through a family, tested and adjusted every time it works. The sperm whale did not stand a chance alone. Most of the time, it would not have been alone. Sperm whales are family animals too, and their numbers are supposed to be their protection. This one had been separated, whether by accident or bad timing, nobody will ever know, and that single fact may have decided everything. Somewhere off the coast of another country, a very different sperm whale is about to prove that being surrounded does not always mean losing. But first, you need to understand exactly what these 2 animals are and why the gap between them is so much bigger than it looks. Line them up side by side and the math stops making sense. A full-grown male sperm whale can stretch 52 feet from nose to tail, longer than a city bus with a head so large it holds almost a third of its body length. It can weigh close to 90,000 pounds, roughly the same as 15 adult elephants pressed into one animal. A killer whale, for all its fearsome reputation, tops out around 26 feet and 8,000 pounds. Put simply, one sperm whale can outweigh a killer whale more than 10 times over. Now picture the fight from the killer whale's side. Its prey has a jaw lined with teeth the size of bananas, built to crush the beaks of giant squid a mile beneath the surface. Its tail alone weighs more than a small car and can swing with enough force to break bone. A single strike in the wrong place could end a killer whale's life in seconds. On paper, hunting a sperm whale looks less like a hunt and more like a dare. And yet, it happens. It happens rarely but often enough that scientists have documented dozens of these encounters across the world's oceans, from the coast of California to the waters near Madeira, off the coast of Portugal. Every single one raises the same question. What would push an animal to risk everything on such a mismatched fight? Part of the answer is food. A sperm whale carries an enormous amount of blubber and meat, enough to feed an entire killer whale family for days. In an ocean where a meal is never guaranteed, that kind of reward can be worth a serious risk. Killer whales are not reckless though, they are calculating. Before committing to an attack, a pod will often circle, test and retreat, reading the target the way a shopper checks the weight of a melon before deciding it is worth carrying home. The other part of the answer is teamwork. No single killer whale would attempt this alone. It takes a coordinated group, each animal playing a role, to have any real chance against a creature many times its size. That kind of coordination does not happen by accident. It is built, animal by animal, generation by generation, inside one of the most tightly knit family structures in the natural world. Scientists tracking these encounters over the past several decades count only a few dozen confirmed cases worldwide, a number small enough that each new sighting adds meaningfully to what researchers understand about this rivalry. Every documented attack, whether it ends with a kill or a retreat, becomes another piece of a puzzle marine biologists are still working to complete. To understand how any of this is possible, you have to look inside both animals, starting with the one that seems, at first glance, impossible to beat. Deep inside the sperm whale's skull sits an organ unlike anything else on the planet. A structure so strange that sailors once mistook it for something else entirely. It holds the key to how this animal survives in total darkness, and it also happens to be nearly useless in a fight against a killer whale. That gap between what a sperm whale can do and what it cannot is exactly where the story begins to turn. A sperm whale's head is enormous, and stranger still once you look inside it. Nearly a third of the animal's entire body length is skull, and packed inside that space is an organ found nowhere else in nature. Early whalers, cutting open dead whales centuries ago, found it full of a waxy, oily substance and assumed, wrongly, that it was tied to reproduction. They named it the spermaceti organ, and the name stuck even after scientists figured out its actual job. That organ works as a sound machine, and it may be the most powerful one on Earth. Sperm whales use it to produce clicks so loud that, up close, they could theoretically damage human hearing and even injure soft tissue. Some recordings have measured these clicks louder than the takeoff of a jet plane. The whale fires this sound like a beam of light through a flashlight, aiming it into the black water ahead to hunt. Here's where the picture becomes clear. Sperm whales spend much of their lives hunting more than a mile below the surface, in waters so dark that eyesight is almost useless. Down there, giant squid drift through a world with no light at all. The sperm whale solves this problem the way a submarine solves it, using sound instead of sight. It sends out clicks, waits for the echo, and builds a picture of everything around it, including prey it could never actually see. This system, called echolocation, works so well that a sperm whale can locate a squid the size of a beach ball in complete darkness from hundreds of feet away. The whale's massive head focuses and amplifies the clicks before sending them out, tuned by millions of years of evolution to survive in a place sunlight has never touched. It is one of the most refined biological tools ever studied. Some of the squid a sperm whale hunts grow long enough to rival a small boat, tentacles included, and the round circular scars often found on a sperm whale's skin tell the story of just how violent that meeting in the dark can turn out to be. Every scar is a small piece of evidence, proof of a battle that took place far below the surface long before any human ever saw it. But here is the twist. All of that power does little to help against a killer whale. Sound can stun a squid or reveal its location in the dark, but a killer whale swimming in daylight at close range does not need to be found. It is already there, circling, watching. The sperm whale's greatest weapon evolved for hunting prey in total darkness. Against a predator that can see it clearly in open water under the sun, that weapon means almost nothing. That leaves the sperm whale searching for other options when a killer whale pod shows up. And on the other side of this standoff sits an animal whose greatest weapon has nothing to do with sound, size, or speed at all. It has to do with what happens inside its brain, and how that brain works together with dozens of others toward a single shared goal. To understand how a killer whale plans an attack, you first have to understand what a killer whale family actually looks like, and it is nothing like the lone hunter most people imagine. Killer whales are dangerous for a reason that has little to do with size or bite force. It has everything to do with what happens inside their heads. A killer whale's brain is one of the largest of any animal on the planet, several times heavier than a human brain, with deep folding in the regions tied to memory, emotion, and problem solving. Scientists who study killer whale behavior describe something closer to strategy than instinct. Before an attack on a large animal like a sperm whale, a pod does not simply charge. It studies. It circles at a distance, testing reactions, watching how the target moves and defends itself. Killer whales have been observed adjusting their approach mid-attack, switching tactics when the first plan fails. Something closer to a coach calling an audible than a wild animal reacting on pure impulse. This kind of thinking shows up clearly in how killer whales hunt other prey. Pods that specialize in sharks have learned to flip them upside down, a trick that puts the shark into a trance-like state, making it easy prey. Pods that hunt seals resting on ice floes have learned to create waves together, timed perfectly, to wash the seal into the water. Every one of these tricks gets learned, tested, and passed down, rather than arriving hardwired at birth. Different pods in different oceans often carry their own version of these tricks, refined over time to fit whatever prey happens to live nearby, the way a family recipe changes slightly depending on which ingredients are available. That last part matters more than almost anything else in this story. A killer whale learns, rather than inherits, the ability to bring down a creature many times its size. Young whales spend years watching older, experienced hunters, learning through repetition, the way an apprentice learns a trade. By the time a killer whale is old enough to take part in a real hunt, it has already watched the exact playbook used dozens of times before. This changes the entire nature of the threat a sperm whale faces. A single clever animal is one thing, a strategy refined across multiple generations, carried inside the memory of an entire family group, and adjusted every single time a hunt succeeds or fails, is something else entirely. Every attack adds new information to that shared memory, making the next attempt sharper. Even the physical layout of a killer whale's brain hints at this. The regions tied to social bonding and communication are unusually developed compared to most other animals, suggesting that staying connected to the group may matter to a killer whale almost as much as finding its next meal. Size alone cannot fully protect against that kind of pressure. A sperm whale might be able to crush a single opponent with one well-placed strike of its jaw or tail, but it cannot outplan an entire family working from decades of collected experience. The real battle happening in the water is instinct against strategy, and strategy tends to win over time. So what does a killer whale family actually look like up close? And how does a single hunting lesson get passed from a grandmother orca all the way down to a calf who has never seen a sperm whale in its life? That answer starts inside the tightest, most loyal family structure found anywhere in the animal kingdom. Forget the image of a lone killer whale slicing through the waves like some kind of ocean wolf. That picture is almost entirely wrong. Killer whales live inside pods built around family, often led for decades by the oldest female in the group. Sons and daughters stay with their mothers for life, and even grown males, fully capable of surviving alone, remain close to their mothers well into adulthood. This matters because knowledge in a killer whale pod does not disappear when one generation dies out. It gets carried forward. A grandmother who has lived through decades of hunts, migrations, and lean years holds a kind of memory bank that younger whales rely on constantly, especially in years when food is scarce. Researchers studying killer whale populations have found that pods led by older, experienced females tend to have better survival rates during hard seasons, almost as if the family carries its own built-in guidebook. Different pods, even in the same stretch of ocean, can specialize in completely different diets and hunting styles, almost like separate cultures living side by side, each with its own habits passed down rather than shared across the wider population. Some pods eat only fish and would never attempt to touch a sperm whale. Other pods specialize entirely in hunting mammals, including seals, dolphins, and occasionally whales many times their own size. A killer whale raised inside a mammal hunting pod grows up, watching those specific techniques over and over until the movements become second nature. Teaching happens constantly and not always gently. Young killer whales have been filmed practicing hunting moves on prey that adults have already weakened, almost like a coach handing a rookie an easy play before trusting them with something harder. A mother might pin a stingray without killing it, then step back and let her calf finish the job, a controlled lesson with real stakes but a manageable amount of risk. Mistakes get corrected in real time, and lessons repeat across dozens of hunts before a young orca is trusted to take part in something as dangerous as an attack on a sperm whale. A calf might spend years simply watching from a safe distance, absorbing the rhythm of a hunt long before it ever plays an active role in one. This is exactly the kind of family structure researchers found behind one of the most extreme events ever documented between these two species, an attack that unfolded off the coast of California and stretched on for 4 full hours. Killer whales working in coordinated waves targeted a group of sperm whales in open water, far from land, in a battle so long and so violent that scientists who reviewed the footage afterward said it changed what they thought they understood about this rivalry between two of the ocean's most capable animals. Nothing about that hunt happened on a whim. That day did not involve a lone predator making a reckless choice. It involved an entire community, built from generations of shared memory, working together with terrifying precision. And at the center of it all sat a group of sperm whales trying to survive using the only defense they had ever needed before that day. What happened next would test that defense in ways nobody had ever recorded before. It started like most ocean surprises with the sighting that seemed routine. Researchers on a boat about 80 miles off the coast of central California spotted a pod of killer whales, roughly 35 in total, moving with unusual purpose. Nearby swam 9 sperm whales, unaware or perhaps already sensing that something had changed in the water around them, the calm surface around them giving no hint of what was about to unfold. What followed became one of the most studied and referenced encounters in the history of whale research. The researchers on board had come out that day expecting a quiet stretch of open ocean, not a front row seat to one of the longest recorded battles between these two species. The attack lasted 4 hours. That is a staggering length of time for any predator to spend on a single hunt, especially in open ocean where energy and oxygen both come at a cost. But the killer whales did not rush. They worked in careful, coordinated waves, sending groups of 4 or 5 animals at a time to strike, then pulling back before the sperm whales could fully retaliate. Scientists later gave this pattern a name: wound and withdraw. Picture a boxer who never stays in range long enough to get hit back. That is close to what these waves of orcas were doing. Instead of committing fully to one prolonged assault, small groups darted in, landed a strike, and retreated before the sperm whale's massive jaws or tails could connect. Over and over, wave after wave, the pattern repeated, wearing the sperm whales down piece by piece rather than risking one dangerous, all-or-nothing charge. Meanwhile, the adult male killer whales in the group did something researchers found especially telling. They held back during the early waves, watching, conserving their strength. Only near the very end, once the sperm whales were exhausted and one had become separated from the rest, did a male orca move in and finish the job. It was, in effect, a division of labor, with different members of the family playing very different roles depending on the stage of the hunt. The sperm shells, for their part, tried to defend themselves using the one trick built into their species for exactly this kind of danger. They clustered together at the surface, heads pointed inward and tails facing outward, forming a shape known as the marguerite, tails fanned out like the petals of a flower. It is a strong defense in theory, a wall of powerful tails ready to strike anything that gets too close, protecting the more vulnerable heads at the center. Every time a wave of orcas pulled back, the sperm whales tightened their circle a little more, an instinctive reaction repeated again and again as the hours dragged on. For most of the sperm whales that day, the formation held. But formations only work as long as every whale stays inside them, and after 4 relentless hours, one animal ended up separated from the group. What happened to that single whale, and exactly how a formation built to protect an entire family can fail for just one member, is where this story turns from a story about survival into a story about loss. Slow this pattern down and it starts to look less like chaos and more like a machine running exactly as designed. Wound and withdraw is not a wild swarm of animals attacking at random. It is a rhythm, repeated with discipline, built to limit risk while raising the damage over time. Each wave of killer whales, usually made up of adult females and their older offspring, moves in fast, delivers a strike, then retreats before the sperm whale can respond with force. Think of it like a swarm of hornets attacking something far larger than any one of them. No single hornet could bring down a large animal alone, and no single sting does much damage on its own. But sting after sting, wave after wave, the target grows weaker, slower, and less able to defend itself. Killer whales apply a similar logic, except with far more coordination, far more intelligence, and a target that can weigh more than 10 of them combined. Why not simply attack all at once with the entire pod? The answer comes down to risk. A sperm whale's tail, called a fluke, can generate enough force to seriously injure or kill a killer whale in a single hit. Charging in as one large group increases the number of animals within striking range at any given moment, raising the odds that at least one member of the pod ends up in the path of a powerful, well-aimed strike. By attacking in smaller, controlled waves, a pod limits how many of its members are ever exposed to danger at the same time, protecting the group's long-term survival even while pursuing a short-term meal. There is also a cost that works entirely in the killer whale's favor. Constant, unpredictable strikes force the sperm whale, or whales, to stay on guard every single second, with no real chance to rest or recover. Exhaustion sets in gradually, dozens of smaller moments stacking on top of each other until strength simply runs out. By the final hour of an attack like the one off California, sperm whales were likely running on fumes, drained gradually, dozens of smaller strikes doing what one dramatic blow never could. This is also where the difference between the sexes inside a killer whale pod becomes clearest. Adult females, often smaller and more agile than fully grown males, take the lead during these early striking waves, relying on speed and coordination rather than raw size. The bulkier adult males mostly wait, holding back their strength for the moment it matters most, usually the final blow against a target too weakened to fight back. It is a strategy built entirely around patience, something few people would expect from an animal known mainly for speed and power. That patience is what separates a killer whale hunt from a simple chase. Speed alone rarely brings down prey this size. Discipline, spread across an entire family working in shifts, does. And patience, as the sperm whales in that encounter would learn, can be just as dangerous as any bite. Their only real countermeasure against a strategy like this had nothing to do with speed or strength either. It relied entirely on staying close enough together that no single whale ever had to face that rhythm alone. When danger closes in, sperm whales do not scatter, they do the opposite. They pull together into a shape scientists call the marguerite, named after a type of daisy, because from above the water it looks almost exactly like a flower in bloom. Each whale points its head toward the center of the group and its tail outward, creating a circle of bodies with the most vulnerable parts protected and the most powerful parts facing outward, ready to strike. Seen from a boat or a drone overhead, the shape is unmistakable, a living ring drawn on the surface of the ocean in a matter of seconds. This is a specific, repeated behavior, observed across sperm whale populations in oceans thousands of miles apart, from encounters near Australia to the coast of California. That kind of consistency tells scientists something important. This formation is not learned on the spot during a single crisis. It is closer to an instinct passed down through generations, built specifically to counter exactly the kind of threat a killer whale represents, refined slowly over a timescale far longer than any single whale's lifetime. Picture a wagon train in an old western film, circling up when danger appears, with the most exposed members protected in the middle. Sperm whale calves and injured or weaker adults tend to end up near the center of the marguerite, shielded by the stronger animals around them. It is, in a very real sense, a family protecting its most vulnerable members using the only tool available in open water, their own bodies arranged into a defensive wall built entirely out of instinct and trust. The tails matter most here. A sperm whale's tail can weigh several thousand pounds and move with enough force to seriously injure almost anything that gets in its way, including a killer whale. By facing outward, every whale in the formation becomes a weapon aimed at the threat, with dozens of powerful strikes ready to fire at once if an orca gets too close. It turns a group of individually vulnerable animals into a single unit that is far harder to attack safely. Scientists studying old whaling records found descriptions of this same formation stretching back centuries, long before anyone understood why the whales were doing it. Proof that this behavior is nothing new to the species. Similar circular defenses show up elsewhere in nature too. Musk oxen in the Arctic form a strikingly similar circle when wolves approach, horns facing outward, calves tucked safely inside. It is one of those patterns that keep showing up across completely different species facing a similar problem, a sign that when the stakes are high enough, similar solutions tend to appear again and again across the natural world. A formation like this depends entirely on one condition though. Every single whale has to stay inside it. The moment one animal drifts, gets separated, or is pulled away by exhaustion or confusion, the entire structure starts to weaken. That single flaw, one whale slipping outside the protective ring, is exactly what turned the 4-hour attack off California into something far more devastating than it should have been. A reminder that even the most disciplined defense is only as strong as its most tired member. Look closer at the marguerite formation and the detail starts to reveal just how well built this defense really is. Sperm whale heads are enormous, dense and packed with the spermaceti organ described earlier, giving them real structural weight and toughness that most predators would think twice before testing directly. Turning that heavily built front section inward, away from an attacking predator, removes one of the easier targets a killer whale might otherwise go Meanwhile, every tail pointed outward becomes part of a rotating wall of defense. Sperm whales do not need to coordinate every single movement with perfect precision to make this work. Even loosely timed strikes from multiple tails, all aimed roughly outward, create a genuinely dangerous zone for any predator trying to approach. A killer whale sizing up the formation has to weigh the risk of a serious injury against the reward of a successful strike. And that math changes the entire nature of the attack, turning what might have been an easy meal into a genuine gamble. Researchers who have observed these formations closely describe something almost mechanical about how quickly sperm whales snap into position once a threat is detected. Within moments of sensing danger, likely through sound and vibration in the water, scattered whales begin closing the gap between themselves, tightening the circle, adjusting their spacing, almost like a marching band correcting its lines during a live performance. Each animal seeming to know its place without any obvious signal passing between them. There's very little wasted motion. This speed matters enormously. A killer whale pod using the wound and withdraw strategy relies on finding gaps, moments of confusion, animals slower to react than the rest. Small openings that usually appear only once exhaustion starts to set in. A tightly formed marguerite closes off almost every one of those opportunities in seconds, forcing the killer whales to either commit to a genuinely risky direct strike or hold back and wait for the formation to weaken on its own, usually through simple exhaustion. And exhaustion, over time, is exactly what tends to happen. Holding a defensive formation for hours takes enormous energy, especially while surfacing to breathe under constant threat. Every whale inside the circle has to stay alert, ready to strike, for the entire duration of the attack, with almost no chance to rest. Muscles built for long, slow dives are not built for hours of tension and sudden bursts of effort, and that mismatch drains a sperm whale's energy far faster than a normal day of hunting ever would. This is precisely the pressure that built up during the California encounter, hour after hour, wave after wave, each cycle chipping away a little more at a formation that had held remarkably well up to that point. The formation did exactly what it was built to do, for almost the entire fight, protecting most of the group from serious harm. But formations are only as strong as their weakest gap, and after 4 hours of relentless pressure, one gap finally opened. What happened in that single moment would turn one of the best defensive strategies in the ocean into a cautionary tale about what happens when even the smallest crack appears. By the 4th hour of the California attack, the sperm whales were not the same animals that had started the fight. Hours of sustained pressure, dozens of individual strikes, and the constant need to surface and breathe while staying in formation had taken a toll that no amount of instinct could fully protect against, wearing down muscle and resolve in equal measure. Somewhere during that exhausting stretch, one sperm whale ended up separated from the protective circle that had held the rest of the group together. Nobody watching from the research boat could say for certain exactly how it happened, and even years of later analysis never fully settled the question. It may have drifted slightly out of position during a wave of strikes. It may have been slower to reposition after surfacing for air. In an ocean fight lasting hours, small mistakes eventually happen, even inside a formation as disciplined as the Marguerite, and it only takes one for the entire balance of the fight to shift. And killer whales, patient and watchful the entire time, were waiting for exactly this kind of opening. Once separated, the sperm whale's odds collapsed almost immediately. Inside the formation, every whale benefited from a wall of tails and the safety of numbers. Alone, even a fully grown sperm whale, powerful as it is, faces a coordinated family of killer whales with nothing standing between them and its most vulnerable points. This is the wound and withdraw strategy applied now with brutal efficiency against a single, isolated target. This is also the moment the adult male killer whales, who had mostly stayed back during the earlier waves, finally moved in. According to researchers who documented the encounter, one adult male made the final approach and delivered the strike that ended the separated whale's life. It was a grim but telling detail, showing exactly how this species divides labor during a hunt, saving its most powerful members for the decisive final moment rather than risking them earlier in the fight. For the rest of the sperm whale group, still holding their formation nearby, there was little they could do. Breaking position to try to help would have meant abandoning the very defense keeping the rest of them alive. In the harsh math of survival, the group's best chance remained staying together, even while one of their own was lost. It is a reminder that even the best defensive strategy in the ocean has limits, and those limits usually appear exactly where a single individual becomes separated from the group protecting it, a lesson written in laws rather than in theory. Word of the encounter spread quickly through the small world of whale researchers, and the detailed account written afterward became required reading for anyone studying how these two species interact. This encounter, studied and referenced by marine biologists for decades afterward, became a kind of blueprint for understanding this rivalry. It showed exactly how effective the Marguerite formation could be, and exactly how it could fail. But California was not the last time these two species would collide. Nearly 3 decades later, on the opposite side of the world, a very different part of sperm whales would face a similar threat, and this time they would reach for a defense nobody had ever properly documented before. Off the southwestern coast of Australia, in a stretch of ocean called Bremer Bay, tourists and marine biologists gather every year hoping to see exactly the kind of dramatic wildlife encounter most people only ever see on a screen. Orcas hunt regularly in these waters, sometimes in pods of more than 50 animals, and sightings of attacks on large prey are part of what draws researchers back season after season, year after year, hoping to add another piece to the record. Even by Bremer Bay standards, though, a stretch of ocean already famous among researchers for dramatic sightings, March of 2024 delivered something unusual. A marine biologist named Jenna Tucker, working aboard a tour boat, watched as a pod of killer whales began pursuing a group of 4 young sperm whales, the kind of moment she had spent years hoping to witness firsthand. Unlike the fully grown adults involved in the California encounter, these were juveniles, smaller, less experienced, and likely more vulnerable to a sustained chase. What followed stretched on for well over an hour, the orcas relentlessly pressing the smaller whales while never quite managing to bring one down. From the deck of the tour boat, passengers who had come out hoping for a calm afternoon of wildlife watching instead found themselves holding their breath through one of the longest sustained chases anyone on board had ever witnessed. As the chase wore on, Tucker noticed something telling in how the sperm whales were behaving. They stayed close together, surfacing repeatedly, breathing heavily, clearly exhausted from the sustained pressure. Anyone watching could see the toll the chase was taking. It was a slow, grinding test of endurance, playing out in real time in front of a boat full of stunned onlookers. Killer whales, capable of bursts approaching 30 miles per hour during an attack, hold a clear speed advantage over sperm whales, which tend to be slower and rely more on maneuvering and formation than raw sprinting power. A mismatch that should have made this an easy chase to finish. Over the course of an hour-long chase, that speed gap should have mattered enormously, giving the orcas repeated chances to isolate and target the smallest, most vulnerable whale in the group. And yet, hour after hour, the young sperm whales held on. They stayed bunched together, using the same instinct toward group defense seen in California decades earlier, denying the orcas the kind of clean opening that had proven so costly before. Tucker and the researchers watching could tell something was building. The whales looked worn down, clearly reaching the edge of their endurance, but they were not giving up either, holding their ground with a stubbornness that surprised everyone on the boat. Then, just as the chase seemed to be reaching its breaking point after more than an hour of relentless pressure, Something happened in the water that nobody on that boat expected to see. A massive, dark shape rose to the surface, spreading outward from the huddled group of sperm whales like a cloud unfurling in slow motion. At first glance, it looked exactly like what everyone feared it might be. What that cloud actually turned out to be would change how scientists understood sperm whale defense. Exhaustion in a marine mammal does not look like exhaustion in a human sprinting to a finish line, but the signs, once you know what to look for, are just as clear. Sperm whales breathe through a single blowhole at the top of their heads, and under normal, relaxed conditions, they surface calmly, take a breath, and dive again with smooth, practiced movement built from a lifetime of repetition. During the Bremer Bay chase, none of that calm remained. Tucker described those whales poking their heads above the surface and letting out loud, heaving breaths, a clear physical sign of an animal pushed close to its limit. Imagine finishing an all-out sprint and gasping for air, chest heaving, barely able to speak. Now imagine doing that while also staying alert for an attack that could come from any direction at any moment. That is roughly the situation these young sperm whales found themselves in over and over for more than an hour. What makes this especially dangerous for a sperm whale is how deeply tied its body is to controlled, efficient breathing. These animals are built for long, deep dives, holding the breath for well over an hour under normal hunting conditions, by carefully managing oxygen use throughout their bodies, slowing their heart rate and redirecting blood flow to the organs that need it most. A prolonged, high-stress chase disrupts that entire system, forcing rapid, inefficient breathing that burns through oxygen reserves the whale would normally save for a long, calm dive far below the surface. The longer the chase continued, the more this mattered. Every minute spent gasping at the surface instead of diving to safety was a minute the Orcas could use to reposition, test the group's defenses, and look for weakness. It became a race against the whales' own bodies as much as a race against the predators chasing them, a slow drain that no amount of instinct or formation could fully stop on its own. Every gasping breath at the surface was a small, visible signal to the watching orcas that their strategy was working exactly as intended. And yet, the sperm whales did not scatter. Despite clear signs of exhaustion, they stayed clustered together, relying on the same defensive logic that had defined the Marguerite Formation decades earlier in California. Breaking apart, even for a moment of individual relief, would have meant handing the orcas exactly the kind of opening that had proven fatal before. Staying together, even while exhausted, remained their best chance at survival. Every extra minute of gasping, disrupted breathing pulled the group further from the kind of recovery a normal dive would allow. This is the moment, biologists later explained, when a group under this much pressure often reaches a final decision point. Either the formation breaks and the hunt reaches its brutal conclusion, or the group finds some other way to change the terms of the fight entirely. What the young sperm whales in Bremer Bay chose to do next was neither of those expected outcomes. It was something researchers had heard about only in scattered, unconfirmed reports before, and watching it happen live would turn out to be one of the strangest documented moments in the entire history of this rivalry. For over an hour, the sperm whales at Bremer Bay had done everything a textbook would predict. They clustered together, endured wave after wave of pressure, and pushed their bodies to the edge of exhaustion trying to hold their formation, doing everything the Marguerite Formation had always asked of them before. Then, as the orcas closed in for what looked like it might be the final push, the sperm whales did something that had almost nothing to do with size, speed, or strength at all. They released a massive cloud of their own waste directly into the water around them, a moment so unexpected that nobody on the boat had a name ready for what they were seeing. Researchers who study this behavior call it defensive defecation, a deliberate response sperm whales use specifically when they feel seriously threatened. It sounds almost too strange to be a real survival strategy, closer to something out of a comedy sketch than serious marine biology, the kind of detail that seems made up until footage proves otherwise. But in the water that day, it worked exactly the way the whales needed it to. The largest of the sperm whales in the group appeared to lead the response, releasing a thick, dark cloud that spread quickly through the surrounding water, as if the entire group had been waiting for exactly this signal. Almost immediately, the other whales in the group began using their tails to churn and spread the substance further, turning what started as a single release into a wide, disorienting cloud covering a large area around the huddled group. From the tour boat, the reaction from the passengers on board was somewhere between confusion and disbelief, nobody quite sure what they were watching unfold in real time. Think about what this does from an orca's perspective. Killer whales rely heavily on sight and sound to track prey during an attack, watching for movement, positioning, and small openings in a group's defense. A system built on clarity that suddenly had none left to work with. A thick, dark cloud suddenly filling the water does more than just look unpleasant. It genuinely disrupts visibility, making it far harder to judge distance, spot an opening, or safely commit to a strike without risking a serious injury from a fluke or jaw hidden somewhere inside the murk. There's also a strong possibility that smell plays a role, though researchers are still studying exactly how much killer whales rely on scent underwater compared to sight. Whatever the exact mechanism, the effect that day, witnessed firsthand from only a short distance away, was unmistakable. Within a relatively short time after the cloud spread, the orcas that had spent over an hour relentlessly pursuing the group began pulling back, eventually abandoning the chase entirely and swimming off in search of easier prey elsewhere. It was, by any measure, an unexpected ending to one of the most dramatic tests of endurance ever documented between these two species. A group of exhausted, outmatched juvenile sperm whales had turned their own bodies into a weapon nobody watching had expected to see, and it worked. But the story of exactly how this strategy functions and why a squid-heavy diet makes it especially effective against a predator like the orca goes even deeper than the chase itself. To understand why this defense works so well, you first have to understand what sperm whales actually eat and how strange that diet really is. Sperm whales spend most of their lives hunting deep below the surface, targeting squid, including giant squid, in total darkness more than a mile down. A diet almost nobody outside of marine biology ever thinks to picture. A single adult sperm whale can eat over a ton of squid in a single day, an enormous amount of food processed constantly through its digestive system, day after day, without any real pause. Squid, it turns out, are messy eaters, and messier still on the way out. Their bodies contain a reddish, ink-like pigment, and when broken down through digestion, that pigment carries through into the whale's waste, giving it a deep reddish orange color unlike almost anything else found in the ocean. It is thick, and under the right conditions it spreads through water in a way that looks strikingly similar to blood. A detail that would matter enormously during the Bremer Bay encounter and shape how everyone on that tour boat first reacted to what they saw. Researchers studying defensive defecation believe the behavior may have developed, at least partly, because this particular waste happens to be so effective as a deterrent against a predator relying on clear water to hunt. A thick, dark, slow dispersing cloud does more to disrupt a predator's senses than a thinner, more watery release would, and the sheer volume a large sperm whale can produce in a single burst adds to the effect. A fully grown adult built to process such an enormous amount of food every day simply has more raw material available for this kind of defense than a smaller animal ever could. Picture pouring a gallon of dark red paint into a swimming pool and watching it spread, clouding the water far beyond what the actual volume would suggest. Something similar happens here, except on a much larger scale, filling a wide area around the whale group almost instantly. For a predator relying on clear sightlines to safely time an attack. That kind of sudden, disorienting cloud changes the entire calculation in seconds. There's a good reason observers on the tour boat at Bremer Bay initially assumed they were looking at blood rather than waste. The color, thickness, and sudden appearance of the cloud matched almost exactly what a serious injury might look like from a distance. It was only after reviewing footage more closely and comparing it with earlier accounts of similar behavior that researchers confirmed what they were actually watching. This detail, the visual similarity to blood, turns out to matter for more than just human observers trying to make sense of a chaotic scene from the deck of a moving boat. It may play a role in how effectively this defense works against the orcas themselves, adding a layer of confusion on top of the physical disruption already caused by the cloud spreading through the water. Exactly how that confusion unfolded in real time, from the perspective of everyone watching that day, from the deck of a boat that had already followed this chase for well over an hour, is where this story gets even stranger. From a distance, watching from the deck of a boat that had followed this chase for over an hour, the moment looked like something out of a nightmare. A massive, dark shape bloomed to the surface near the huddled group of sperm whales spreading fast, and everyone on the tour boat assumed the worst. Tucker later described her own first reaction clearly. She thought she was watching one of the whales bleed out after over an hour of sustained attack, the tragic but expected ending to a chase that had already pushed the animals to their limits. For a few tense moments, watching from just a short distance away, that assumption made complete sense. A cloud that dark spreading that quickly matched exactly what a serious wound might produce in open water, and nothing about the moment suggested any other explanation. Researchers and tourists alike braced for the worst, watching closely to see which whale might be injured and how badly. In a situation already defined by exhaustion and danger, a growing red cloud felt like confirmation that the hunt was finally reaching its brutal conclusion, the outcome everyone on board had been dreading for the past hour. It took a closer look and a calmer moment to process what was actually happening, for the true picture to come into focus. The substance was waste, released deliberately by the largest whale in the group as the pressure of the chase reached its peak. Once researchers realized what they were actually looking at, the entire scene shifted from what looked like a tragedy into something closer to a clever, last resort defense playing out in real time, right in front of a boat full of people who had feared the worst only moments earlier. This kind of confusion is common, even among trained observers. Reddish, blood-colored water immediately triggers a very specific, understandable assumption in anyone watching a predator attack unfold. The mind jumps straight to the most obvious explanation, especially in a high-stress, fast-moving situation happening on open water from the deck of a moving boat. It took reviewing recorded footage afterward, frame by frame, to confirm exactly what had taken place. Even then, the resemblance was close enough that early clips shared among researchers came with a warning attached, reminding viewers what they were actually looking at before the footage spread any further. There is something worth sitting with here. The very same visual confusion that briefly fooled trained marine biologists watching from a boat may also work, in some form, against the killer whales themselves in the middle of an attack. A sudden burst of dark, blood-colored liquid, appearing without warning in the middle of a chase, could plausibly cause a moment of hesitation in a predator relying on clear visual information to safely time its next move. Whether or not that specific effect on the orcas has ever been proven scientifically in a controlled setting, the outcome witnessed that day spoke for itself. Confusion, whether visual, chemical, or some combination scientists are still working to fully understand, appeared to buy the sperm whales exactly the kind of opening they needed. What happened immediately after the cloud appeared, as the whales began actively working to spread it further through the water, would turn a moment of chaos into a fully coordinated group defense. Releasing the waste, dramatic as it looked from the boat, was only the first half of the strategy. On its own, a single cloud, even a large one, would eventually settle, thin out, or drift away with the current, leaving clear water behind within minutes. The sperm whales at Bremer Bay were not finished, not while the Orcas still lingered close enough to strike. Almost immediately after the initial release, the group began actively using their tails to churn the water, spreading the cloud wider and thicker than it ever would have reached on its own. A sperm whale's fluke can measure over 10 feet across on a fully grown adult, capable of moving an enormous volume of water with a single sweep, more than enough force to turn a small, contained cloud into something much larger within seconds. By repeatedly sweeping their tails through the released waste, the whales turned a contained cloud into a wide, disorienting field covering a much larger area of ocean around the entire group, far beyond what one single release could ever have managed alone. It was less a byproduct of panic and more an active, coordinated effort by animals working together under pressure. Picture stirring a pot of thick soup with a large spoon, watching the color spread and blend through the entire pot in seconds rather than staying contained in one small corner near the edge. That is roughly the scale of effect a full-grown sperm whale tail can create underwater, especially with multiple whales working the same general area at once. What started as one whale's release became, within moments, a shared defensive tool used by the entire group, every animal contributing to a single, unified cloud, rather than leaving the job to one exhausted whale alone. This detail, small as it might seem, matters because it shows something beyond simple instinct. A single, reflexive release of waste under extreme stress would be one thing, easily explained as pure panic. Actively working together afterward, using tails deliberately to spread and thicken that cloud, points towards something closer to a coordinated tactic, possibly one refined across generations the same way killer, whale hunting strategies have been. Researchers studying this behavior have started comparing it, cautiously, to other defensive tactics seen across the animal kingdom, where an otherwise vulnerable species uses a sudden, disorienting release to buy critical seconds against a faster or far stronger predator. Certain squid and octopus release ink clouds for a strikingly similar purpose, disrupting a predator's ability to track them clearly in the crucial moment right after an attack begins. Finding that same basic idea in an animal many times larger than any squid suggests this kind of defense may be a far older survival trick than anyone realized. For the young sperm whales caught in this exact situation, those extra seconds and that extra confusion may have made all the difference. With visibility disrupted across a wide area and orcas forced to slow down and reassess rather than commit to another confident strike, the entire rhythm of the attack shifted. The relentless pressure that had defined the previous hour suddenly gave way to something the sperm whales had not experienced during the entire chase, a moment where the orcas, for the first time, appeared uncertain about what to do next. Uncertainty, for a predator mid-hunt, tends to be costly. Killer whales that had spent well over an hour pressing the group of young sperm whales, testing their formation and waiting for an opening, suddenly found themselves working through a thick, disorienting cloud that made every one of those careful calculations far harder to trust. Strikes that had felt calculated minutes earlier now carried real risk of connecting with the wrong target in murky, reddish water. What happened next surprised everyone watching from the boat, including researchers who had studied this rivalry for years and thought little about it could still catch them off guard. Rather than pushing through the confusion and continuing the attack, the orca pod began pulling back, slowly at first, then more decisively. The killer whales that had dominated the chase for over an hour started drifting away from the huddled sperm whales, eventually abandoning the pursuit entirely and heading off in search of other, presumably easier prey elsewhere in the bay. For a species known across the ocean for its intelligence and persistence, walking away from a target that close to exhaustion was a striking decision, one that reveals just how carefully these animals track the odds during a hunt, rather than simply pushing forward out of habit. It suggests something important about how killer whales weigh risk during a hunt, even one they have already invested significant time and energy into. A sudden shift in conditions, one that makes success less predictable and injury more likely, appears capable of tipping that calculation, even after more than an hour of committed pursuit. For animals that hunt using careful planning rather than blind aggression, an unreliable target quickly becomes a target worth abandoning. Tucker and the other researchers who documented the encounter described the moment with genuine astonishment. Clear accounts of defensive defecation used during an active orca attack had been extremely rare before this sighting, more often mentioned in passing reports than captured on video from start to finish. Watching the entire sequence unfold in real time, from initial chase through exhaustion, the release, the spreading cloud, and finally the orcas retreating, gave scientists a rare, complete picture of a defense mechanism that had mostly existed as scattered anecdotes before that day. For the young sperm whales, battered and clearly exhausted after their ordeal, the outcome represented something close to a best-case scenario. They had survived a sustained, coordinated attack from one of the ocean's most capable predators, using nothing more than group formation, endurance, and a defense mechanism built from their own bodies. No whale in the group appeared to have suffered a serious injury, a genuinely rare outcome for an encounter that had gone on for so long against such determined attackers. This single encounter, captured almost entirely by accident, opened a door researchers are still working to fully understand. If waste can disrupt an attack this effectively, what other overlooked defenses might sperm whales be relying on that nobody has properly documented yet? As it turns out, waste was far from the only trick these whales had. Long before an orca ever gets close enough to trigger a chase like the one at Bremer Bay, sperm whales may already be listening and reacting to a threat they cannot even see. Somewhere beneath a calm patch of ocean, far from any tour boat or research vessel, a sperm whale can sense danger long before a single killer whale comes into view. It does not need to see a black and white fin cutting through the water. A sound alone, carried through water far more efficiently than through air, can be enough to trigger a full defensive response. Sound moves through water roughly 4 times faster than it moves through air, and travels for miles beyond where a killer whale could ever be spotted by eye. That difference turns hearing into an early warning system no amount of visibility could ever match. Killer whales, like sperm whales, communicate using sound, and different groups produce distinct calls, depending on what they hunt and where they live. Mammal-eating killer whales tend to stay quieter overall, calling less often than fish-eating groups, likely because the prey, including seals and other whales, can hear and react to those same calls. But when mammal-eating orcas do call, especially during a coordinated hunt, that sound carries a warning nearby cetaceans have learned to recognize. Sperm whales appear to be no exception. Scientists studying this question wanted to know exactly how a sperm whale responds the moment it hears the specific calls used by orcas that hunt marine mammals, calls it may never have heard from an actual visible predator before. The results turned out to be stranger and more revealing than anyone expected. Instead of simply swimming away, which might seem like the obvious response to a predator's voice, sperm whales exposed to these calls showed a change in behavior that looked almost social. Feeding dives were abandoned midway. Whales that had been diving alone began surfacing and gathering, seeking out the company of others nearby, exactly the kind of grouping behavior seen during a real, visible attack. This response makes more sense once you remember what a sperm whale's greatest strength actually is. Diving deep and hunting in darkness works brilliantly against squid, but it does little to protect against a killer whale circling at the surface. A lone sperm whale caught mid-dive, hundreds of feet down, has no formation to hide inside and no group of tails to rely on. Surfacing and gathering, even before any orca is actually visible, gives a whale time to prepare a defense that dive depth alone could never provide. What makes this discovery even more remarkable is where and on whom it was tested. The whales involved were not part of a tightly bonded group living together year-round. They were solitary adult males, animals that, under normal conditions, spend most of their lives keeping their distance from other sperm whales entirely. Getting animals like that to respond as a group triggered by nothing more than a recording played through an underwater speaker revealed something scientists had not fully appreciated about how deep this instinct runs. Somewhere off the coast of Norway, in cold water far from the tropical breeding grounds where most sperm whale research usually happens, a team of scientists ran exactly this kind of experiment, tagging animals that almost never allow anyone to study them this closely. Getting close enough to attach even a single tag to a wild adult male sperm whale took months of patient planning before the real experiment could begin. What they recorded, dive by dive, would become one of the clearest windows anyone has ever had into a sperm whale's mind under threat. The Norwegian Sea is not where most people picture sperm whale research taking place. Cold, rough, and far from the warm breeding grounds near the equator, these waters are mainly home to solitary adult males, animals that travel here alone once they leave their mother's groups behind for good. It is exactly the kind of remote, difficult location a team of scientists chose when they set out to test how these whales respond to danger they cannot see. A location that made the entire project harder to carry out but far more revealing once it succeeded. The plan itself was fairly simple to describe, even if carrying it out at sea was anything but. Researchers attached small multi-sensor tags to 5 male sperm whales, devices capable of recording depth, movement, and sound as the whale went about its normal life below the surface. Each tag stayed attached only temporarily, held in place with suction cups rather than anything permanent, giving the team a limited window to gather data before it eventually released and floated to the surface for retrieval. Once a tag was in place and the whale had resumed a regular dive pattern, the team played a recording through an underwater speaker, a call used by killer whales that specialize in hunting marine mammals. Then they watched and waited to see exactly how each whale would respond. The results were consistent enough to catch the attention of researchers well beyond the study itself. Rather than continuing the dive or reacting only mildly, the tagged males cut the dive short and headed back toward the surface, often faster than they had been descending only moments before. Once there, several of the whales began behaving in ways that looked distinctly social, an unusual choice for animals that typically spend the vast majority of their time completely alone. This detail matters more than it might first appear. A solitary male sperm whale, hundreds of feet down and far from any other whale, would normally have no reason to seek out company. Diving away, deeper into the darkness where a sperm whale's biosonar gives it every advantage, might seem like the safer choice on paper. Instead, these males chose the surface and the presence of others. The moment a threat entered the picture, even a threat made entirely of recorded sound played through a speaker rather than delivered by an actual predator swimming nearby. Researchers who ran the experiment describe this as strong evidence that grouping together rather than simply fleeing is the anti-predator strategy sperm whales default to when facing killer whales, regardless of whether they are normally social animals at all. It suggests the instinct to form something like a defensive cluster runs deep enough to override an otherwise solitary male's typical behavior in an instant, switching on almost like a reflex the moment the right sound reaches its ears. There was something else buried in the data too, something that would only make full sense once researchers looked more closely at the actual sounds these frightened, isolated males began making once they reached the surface. Solitude was not the only thing these animals were willing to set aside the moment danger appeared. Their usual silence went with it. On the surface, diving away looks like it should be the obvious move. Sperm whales are among the deepest diving mammals on the planet, capable of descending more than a mile below the surface and staying there for well over an hour at a time. A killer whale, by comparison, is built for speed near the surface, not for chasing prey into the crushing pressure and total darkness of the deep ocean, water that would push a mammal built for shallow hunting far past its natural limits and offer it no real advantage even if it tried. Logic suggests the safest place for a sperm whale to hide from an orca would be exactly where an orca cannot easily follow. Again and again, though, that is not what sperm whales choose to do. The behavior recorded off Norway and elsewhere points in exactly the opposite direction, toward the surface rather than away from it. Part of the answer comes down to timing. Diving to real safety, far enough down that a killer whale genuinely cannot reach, takes time, often many minutes of steady, controlled descent. Minutes a whale under active pursuit simply does not have to spare. A whale caught by surprise, already at a shallow depth or resting near the surface, simply does not have that kind of head start available. By the time it reached anything close to a safe depth, an orca moving at full speed could easily close the distance first. There's also the matter of what actually works once a threat is close. Depth protects a sperm whale from a predator it cannot see or has not yet located, buying time and space before any confrontation begins. But once a killer whale pod has already found a whale and started circling, distance stops being the most useful defense. At that point, the fight, if there's going to be one, happens at or near the surface, where breathing is required and where a formation of grouped whales can actually put its wall of tails to use, something no amount of open water below could ever offer on its own. This is where the Marguerite Formation and its underwater cousins make far more sense as an answer to this specific threat, rather than an old evolutionary reflex left over from some other purpose entirely unrelated to killer whales. A killer whale pod hunting cooperatively wants the exact opposite of what a scattered group of diving whales would give it. It wants isolated targets, easier to separate and wear down one at a time. Gathering together at the surface denies that advantage immediately, forcing the orcas to face a defended group rather than picking off individuals hiding alone in the depths. Seen this way, the choice sperm whales make reflects a different kind of logic entirely, one built around numbers and formation rather than depth and darkness, the same logic that shaped every documented encounter examined so far in this story. Deep diving remains an extraordinary hunting tool, capable of taking a whale somewhere almost nothing else in the ocean can follow, into a world built entirely around darkness and pressure. Against a coordinated predator working as a team, though, it turns out that company matters more than distance ever could. Every sperm whale click serves a purpose, but not all of them are used for hunting. Mixed in among the long, steady streams of clicks a sperm whale uses to locate squid in the dark are shorter, more structured bursts, pattern sequences that scientists call codas, distinct enough from ordinary hunting clicks that even a listener unfamiliar with whale sound can often tell the two apart. Unlike the hunting clicks described earlier, codas are not aimed forward like a beam of sound searching the darkness. They appear to be a form of communication, whale speaking directly to whale. A coda usually consists of somewhere between 3 and 40 clicks, delivered in a specific rhythm that can repeat, with slight variation, across an entire group. Researchers have found that different clans of sperm whales, living in different parts of the ocean, use distinct sets of codas almost like separate dialects of the same underlying language, each clan recognizable by its own particular rhythm, the way a listener might recognize a regional accent within a shared spoken language. A sperm whale raised in one clan clicks in a pattern that a whale from a completely different clan, even one living in the same general region, would rarely, if ever, produce. Mothers and calves rely on codas constantly, even outside of any moment of danger. A calf too young to dive deep enough to hunt alongside its mother waits near the surface while she disappears into the depths for a long feeding dive, sometimes for well over an hour at a time, entirely out of sight and out of any direct contact. During that entire stretch, other adult whales in the group often stay near the surface with the calf, and researchers believe codas exchanged during this time may help maintain contact and reassurance between a mother and her young. What makes codas especially interesting in the context of danger is how they change under stress. The study of high-latitude male sperm whales harassed by orcas found something researchers had not expected from animals usually thought to travel and behave largely alone. Adult males, normally silent and solitary in these cold, remote waters, produced codas during these encounters, patterns more typical of the tightly bonded family groups found near the equator, thousands of miles away from where these particular males were recorded. That detail suggests something significant about how deeply this form of communication is wired into the species as a whole. Even males that spend nearly their entire adult lives away from any family group appear to carry the ability, and perhaps even the instinct, to use codas the moment real danger appears. A language mostly reserved for family life gets pulled out and used. The instant survival is on the line, evidence that these clicks carry meaning far beyond simple hunting. Scientists are still working to fully translate what any specific coda actually means, whale to whale, the way a written language can be translated word for word. But every recording collected during a documented orca encounter adds another piece to that growing puzzle, another clue toward understanding exactly what one of the largest brains in the ocean is trying to say when its life depends on being understood, and by whom that message is meant to be heard. Not all sperm whales face a killer whale attack the same way, and the difference comes down almost entirely to where in the ocean and among whom a whale happens to be swimming. Adult males, once they leave the mother's groups behind, migrate toward colder waters near the poles, where food is often more plentiful but company is scarce, trading the safety of numbers for a richer, more solitary hunting ground. Females, calves, and younger whales, meanwhile, tend to stay in warmer waters closer to the equator, living in tight matriarchal groups for essentially their entire lives. This split creates two very different relationships with danger. A female sperm whale near the equator is almost never truly alone. She lives surrounded by relatives, sisters, aunts, and grown daughters, animals she has likely known and traveled alongside for years or even decades, forming bonds that rarely break for the rest of her life. When a threat appears, the Marguerite formation described earlier is not some rare, last resort tactic. It is simply what an already close, cooperative group does under pressure, an extension of habits built through a lifetime of staying together. An adult male in cold, high-latitude water faces a very different situation. He has spent years, often decades, living largely apart from other sperm whales, relying on size and solitary strength rather than group defense, a strategy built for survival alone rather than survival among family. When danger appears in these waters, there is frequently no ready-made family group nearby to form a formation with at all. Instead, as researchers studying these encounters found, unrelated or loosely associated males sometimes come together temporarily, cooperating in ways that look almost improvised compared to the practiced defense of a lifelong family unit. This distinction may explain part of why male and female sperm whales show such different responses to the exact same kind of threat. A female's group already has the trust, coordination, and shared history needed to lock into formation almost instantly, without a single moment spent deciding whether the whale beside her can be relied upon. A male, forced into sudden cooperation with whales he may barely know, has to build that same level of trust in real time, under the worst possible circumstances, while a predator is actively testing the group's defenses. There's a reward buried inside this risk though. Cold, high-latitude waters tend to hold fewer killer whale pods that specialize in hunting large whales compared to some other regions of the world, meaning a male sperm whale, while more isolated, may also face fewer real encounters over the course of its life, than a female raising calves in busier, warmer waters closer to shipping lanes and coastlines. Neither strategy guarantees safety. Both come from the same species solving the same basic problem in two very different social worlds, shaped by decades of separation between the sexes that begins the moment a young male leaves his mother's side for the last time and does not typically return to that group again. What happens when a whale from either of these worlds ends up completely alone, with no group at all to rely on, is where this story turns towards some of its most dangerous encounters yet. Return to the water off the Bay Islands of Honduras, 30 miles from shore, where 3 fishermen had drifted, by accident, into the middle of an active killer whale attack. They had gone out that morning expecting nothing more unusual than a normal day trailing a line behind their boat. By the time the boat came close enough to see clearly, the fight had likely already been underway for some time, the water around the animal streaked with red, the sperm whale still struggling against 3 coordinated attackers. What the anglers witnessed that day, and later shared with researchers, became the first confirmed record of killer whales hunting a sperm whale in that entire stretch of the Caribbean Sea. Marine biologists who studied the footage afterward noted just how rarely encounters like this get documented in this particular region, a part of the ocean far less studied than the waters of California or Western Australia, where most of the earlier accounts referenced throughout this story took place. The sperm whale involved was small, likely a young animal separated from whatever group it may have once belonged to, measuring under 20 feet, far shorter than the fully grown adults described in earlier chapters. That size difference mattered enormously. A young, isolated whale like this one had no marguerite formation to retreat into, no wall of grouped tails to make an orca think twice. It faced 3 killer whales with nothing standing between them and its most vulnerable points from the very first strike. Researchers examining the encounter afterward described the attack as coordinated and deliberate, unfolding in distinct waves rather than one single chaotic rush. That pattern should sound familiar by now to anyone who has followed this story from the beginning. It echoes the same wound and withdrawal rhythm documented decades earlier of California, just scaled down to a smaller family of attackers working against a smaller, more vulnerable target. By the time the fisherman's boat drew close enough to observe clearly, the outcome of the fight was already becoming difficult to mistake. The water carried the unmistakable signs of a battle nearing its end, and the sperm whale's movements had slowed considerably compared to what witnesses described from earlier in the encounter, the fight clearly tilting further with every passing minute. Unlike the story at Bremer Bay, there was no group of exhausted allies nearby to help spread a defensive cloud, no larger pod to lean on for numbers. This encounter, published afterward in a scientific journal focused on marine mammals, added something important to the broader record of this rivalry. It confirmed that Orcas hunting sperm whales was not limited to the handful of regions where most previous sightings happened to occur. Regions that had simply drawn more research attention over the years. Wherever solitary, vulnerable sperm whales and coordinated killer whale families overlap, this kind of encounter appears capable of happening, whether or not anyone happens to be nearby with a boat and a phone to record it. The identity of the attackers in this particular case turned out to be just as revealing as the outcome itself. A family structure that looked almost nothing like the large, all-female hunting parties described in the California encounter. Unlike the pod of 35 orcas involved in the California attack, the killer whales of Honduras numbered just 3. An adult male, a mother, and her calf worked together against the sperm whale, a family unit small enough that every single member likely played an active, direct role in the hunt rather than watching from a distance the way the largest adult males did during the earlier, much larger California encounter, where dozens of relatives could share the workload of wearing down a much bigger group. This detail challenges a pattern that had started to feel established by this point in the story. In the California attack, adult male orcas mostly hung back, conserving their strength for a decisive final strike delivered only once the sperm whale group was already exhausted from hours of sustained pressure. Off Honduras, with only 3 orcas total and no large supporting cast of adult females available to lead the early waves, the adult male appears to have taken a far more direct, hands-on role throughout the entire encounter from start to finish. Researchers who reviewed witness accounts described the attack unfolding in waves, consistent with the wound and withdrawal patterns seen elsewhere, even with such a small group of attackers working through the encounter. Each orca appeared to take turns approaching and striking, giving the others brief moments to reposition before pressing forward again. Even without the numbers available to a larger pod, this small family had clearly learned, and could still execute, the same basic coordinated strategy passed down through generations of killer whale culture. The presence of the calf raises an especially interesting question. Young orcas typically spend years watching before taking any direct role in a genuinely dangerous hunt, according to what researchers have documented in other, better studied populations elsewhere in the world. A hunt against a sperm whale, even a small one, carries real risk from a single well-placed strike of a tail or a jaw. Whether the calf involved in this particular encounter played an active role in delivering strikes, or mainly stayed close by, observing from a safer distance while the adults did the more dangerous work, remains something researchers are still working to determine from the available footage. What the encounter does make clear is that hunting a sperm whale does not require the massive numbers seen off California. A small, tightly coordinated family, applying a strategy built and refined over generations, proved capable of overwhelming a solitary, undersized target using nothing more than patience and teamwork. The same basic ingredients seen in every successful attack examined so far in this story. Numbers matter, but they are not the only factor that decides whether an attack like this succeeds or fails. Even a family this small carried enough collective memory, passed down through generations before this particular hunt ever began, to execute a strategy most people would assume required dozens of coordinated animals rather than just 3. This particular hunting party, built around a mother, her calf, and 1 adult male, points towards something else worth examining closely. Exactly how a mother orca teaches and hunts alongside her own calf during an encounter this dangerous, and why that particular family structure might make for one of the most effective and most motivated hunting units in the entire ocean. A mother killer whale teaching her calf to hunt seals or fish is one thing. A mother bringing that same calf along during an attack on an animal many times the size of both of them combined is something else entirely, and it reveals just how seriously killer whale families treat the passing down of dangerous, hard-won knowledge from one generation to the next. Killer whale calves stay closely bonded to their mothers for years, often well beyond the point where they could technically survive on their own out in open water. During that extended childhood, a calf does not simply watch hunts from a distance and absorb lessons passively. Mothers have been observed actively involving their young in real hunts, adjusting the difficulty and danger based on what a calf seems ready to handle, the same way a parent might hand a child more responsibility only once earlier lessons have been mastered. This creates an unusual kind of danger during an attack like the one off Honduras. A lone adult orca, or even a pair, might choose caution when facing a large or unpredictable target, weighing risk against reward the way any calculating predator would before committing fully to a fight. A mother with a calf nearby carries an additional motivation layered on top of simple hunger, successfully bringing down difficult prey while her calf watches, or even participates, builds skills that calf will rely on for the rest of its life. Skills that could eventually mean the difference between an entire future population thriving or struggling to feed itself in lean years ahead. Researchers who study killer whale culture have noted that calves raised by mothers skilled at hunting large, dangerous prey tend to grow into adults capable of the same specialized techniques, while calves raised in fish-focused pods rarely develop those skills at all, even if genetically capable of it under different circumstances. Knowledge like this does not pass through instinct alone. It passes through direct experience, hunt after hunt, much of it happening specifically because a mother chose to bring her calf along rather than leave it somewhere safer. This also helps explain why small family units, like the trio documented off Honduras, can prove just as dangerous as a massive coordinated pod working with far greater numbers on its side. A mother orca is not simply hunting for a meal in that moment. She's actively building the next generation's ability to survive and hunt independently, a motivation strong enough to justify real risk against prey, many times her own size. Scientists studying these family dynamics point out that this kind of motivation rarely shows up so clearly in other predators, most of which hunt purely to satisfy immediate hunger rather than to prepare an offspring for decades of independent survival still to come. For a sperm whale caught alone in water like this, facing a mother orca determined to teach as much as to eat, the odds shift in a way that has little to do with raw numbers at all. It comes down to what each orca in the group, including the smallest member, has to gain from seeing the hunt through to the end, a stake that goes far beyond the next meal alone. Not every sperm whale involved in this rivalry belongs to the giant species that has filled most of this story so far. Off the coast of Madeira, a small volcanic island in the Atlantic Ocean near Portugal, whale watchers recently captured something rarely seen anywhere in the world: killer whales hunting a much smaller relative of the sperm whale known as the pygmy sperm whale, an animal most people have never even heard of. Despite sharing part of its name and a similar general body shape, a pygmy sperm whale is a completely different animal from the giants described throughout earlier chapters, where a full-grown male sperm whale can stretch beyond 50 feet. A pygmy sperm whale typically measures somewhere around 10 to 12 feet long, closer in size to a large dolphin than to the ocean giant most people picture when they hear the words sperm whale spoken aloud. It lives far from shore, diving deep in search of squid, and stays so far offshore that even experienced researchers rarely encounter one alive, let alone catch one on camera during an actual attack. That rarity is exactly what made the sighting of Madeira so remarkable. Passengers on a whale-watching boat noticed something strange in the water from a distance, an unusual reddish cloud stretching across a wide stretch of ocean that nobody on board could immediately explain. As the boat moved closer, it became clear this was not the same defensive tactic documented earlier at Bremer Bay. This time the color in the water came from an animal that had already been caught. 3 killer whales worked together on the hunt. Witnesses described one orca throwing the smaller whale into the air, while another held the injured animal beneath the surface, the two working in close coordination throughout. At one point, an orca surfaced near the boat itself, the pygmy sperm whale still held in its jaws, almost as if displaying the result of the hunt to the stunned onlookers watching nearby. Researchers familiar with killer whale activity in the waters around Madeira noted that killer whales are seen in the region only a handful of times each year, making any documented hunt here valuable on its own, regardless of which species happens to be involved. A confirmed kill involving a pygmy sperm whale, a species almost never observed being preyed upon anywhere in the world, made this particular sighting even more significant, adding a genuinely new species to the growing list of animals known to fall victim to coordinated orca attacks. Video and photographs from the encounter later circulated among researchers studying killer whale populations across the Atlantic, offering a rare, detailed look at behavior most scientists had only ever pieced together from scattered, second-hand reports. Unlike the fully grown sperm whales able to form a marguerite or unleash a cloud of defensive waste, a pygmy sperm whale, smaller, more solitary, and less studied overall, may simply lack the size and social structure needed to mount any comparable defense against a coordinated attack. Exactly what defenses this smaller relative does rely on, if any, remains one of the many open questions still surrounding one of the ocean's most elusive and least understood animals. Look back across every documented encounter covered so far in this story, and a clear pattern starts to emerge. The California attack ended with the death of a single separated whale, cut off from the safety of its group. The Honduras encounter targeted a young whale under 20 feet long with no formation available to protect it. Off Madeira, the victim belonged to an entire species built on a smaller scale than the giants most people associate with the name sperm whale, lacking the size to make any real defense possible in the first place. Size, or the lack of it, keeps showing up as the deciding factor. This should not come as a surprise once you consider the math involved from a killer whale's perspective. A fully grown adult sperm whale protected inside a tight marguerite formation represents genuine danger, capable of seriously injuring or even killing an attacking orca with a single well-placed strike of a jaw or a tail. A smaller, younger, or isolated whale carries almost none of that same deterrent power. Its strikes are weaker, its formation options are limited or non-existent, and its ability to sustain a prolonged defense, the kind seen for hours at Bremer Bay, simply has not developed yet. Younger sperm whales also lack something less visible but equally important: real-world experience earned through survival. Adult whales that have survived previous close calls, whether real attacks or simply the accumulated knowledge passed down through a group, know how to tighten a formation quickly, how to angle a strike effectively, and how to recognize the earliest signs of an approaching threat. A young or inexperienced whale, especially one separated from any group capable of teaching these lessons directly, faces a killer whale pod without that same accumulated advantage working in its favor. There is a cruel efficiency in how killer whales appear to exploit this gap between potential and actual strength. The wound and withdraw strategy documented during the California attack specifically targets weakness, probing for exactly this kind of vulnerability before committing to a final, decisive strike. A pod does not need to overpower an entire group of healthy adult sperm whales all at once. It only needs to identify, isolate, and outlast the single weakest member, whether that weakness comes from age, size, injury, or simple separation from the group. This pattern extends well beyond sperm whales specifically. Across the ocean, killer whales hunting gray whales, humpbacks, and other large marine mammals overwhelmingly target calves and juveniles rather than fully grown, healthy adults capable of serious retaliation against an attacking pod. It is a strategy refined across countless generations, aimed squarely at the gap between an animal's raw potential size and the actual strength, experience, and protection it currently has available in the moment danger arrives. Understood together, these three encounters read less like isolated tragedies and more like proof of a single, consistent rule playing out across three completely different oceans, three different families of orcas, and three very different victims. Not every killer whale, however, is even built or raised to pursue prey like this in the first place, a distinction that turns out to matter just as much as the size of whatever whale happens to be swimming nearby. Killer whales look identical from a distance, the same black and white pattern, the same tall dorsal fin, the same unmistakable silhouettes breaking the surface. Beneath that shared appearance, though, hides one of the more surprising splits found anywhere in the animal kingdom, one that took researchers decades of patient observation to fully uncover. Different killer whale populations do not all hunt the same prey, and in many cases, groups living in the exact same stretch of ocean never eat the same thing at all. Scientists studying killer whale populations off the Pacific coast of North America were among the first to document this clearly, identifying what are now called distinct ecotypes living side by side without ever truly mixing. Some populations, often called residents, feed almost exclusively on fish, particularly salmon, and travel in large, vocal, tightly bonded groups. Other populations, sometimes called transients, hunt marine mammals almost exclusively, including seals, dolphins, and occasionally whales, many times their own size, and tend to travel in smaller, quieter groups, likely to avoid alerting prey that can hear their calls from a distance. These two types of killer whales share the same waters, sometimes passing within sight of each other, yet almost never interact, hunt together, or interbreed, behaving in some ways more like two entirely separate species sharing one coastline. Researchers studying their genetics have found differences significant enough that some scientists argue these ecotypes may eventually be classified as separate species entirely, despite looking nearly identical to the untrained eye. This split explains something important about the encounters described throughout this story. Every documented attack on a sperm whale involved killer whales belonging to a mammal hunting population, animals raised from birth watching and eventually practicing exactly this kind of hunt against exactly this kind of target. A fish-eating orca, even one swimming directly past a struggling sperm whale, would have little learned reason and likely no practical skill to attempt anything like the coordinated attacks described in earlier chapters. Diet, in other words, works closer to an inherited culture than a simple matter of convenience or opportunity, passed down from mother to calf across generations, shaping everything from hunting technique to social structure to the specific sounds a group uses to communicate. A calf born into a mammal hunting family learns to hunt mammals. A calf born into a fish hunting family learns an entirely different set of skills, one that may never include anything resembling an attack on a sperm whale at all. A calf watching its mother chase salmon through a river mouth learns an entirely different set of muscles, timings, and instincts than a calf watching its mother corner a struggling sperm whale in open water. And neither calf could easily switch to the other's specialty later in life even if it wanted to. Understanding this distinction changes how rare these encounters really are. Killer whales do not simply choose to skip hunting sperm whales most of the time, the way an individual animal might pass up an easy meal out of caution. Only a specific subset of killer whale culture, carried forward through specific family lines and specific mothers teaching specific calves, ever develops the skills needed to attempt it in the first place. Passing down a skill this dangerous does not happen through a single lesson delivered once and remembered forever. It happens gradually across years, built from countless smaller moments a young orca spends simply watching, long before it ever takes an active role in anything resembling a real hunt. One of the clearest examples of this kind of teaching comes from a population of killer whales off the coast of Argentina, near a stretch of beach called Punta Norte. Here, orcas have developed an extraordinary and genuinely risky hunting technique, intentionally beaching themselves in shallow water to grab sea lion pups resting near the shoreline, then using the next incoming wave to push themselves back out to open water before the tide can strand them for good. A single mistake in timing could leave an orca stranded, exposed, and in serious danger, a risk severe enough that only a population raised specifically around this technique would ever attempt it at all. Researchers who studied this population found that young orcas do not simply attempt this technique on their own, driven by instinct alone with no coaching or correction along the way from anyone more experienced. Mothers actively guide their calves through the process, sometimes appearing to physically nudge or position a young whale during early, low-stakes attempts, correcting mistakes and adjusting the calf's approach across repeated practice sessions that can stretch across several years before a young orca performs the full technique independently and successfully. This same pattern of careful, extended teaching almost certainly applies to the far more dangerous skill of hunting a sperm whale, even though nobody has ever managed to film the earliest stages of that particular education directly from start to finish. A young orca growing up inside a mammal hunting pod likely spends years simply present during hunts targeting smaller prey, watching how adults read a target's movement, how they time their strikes, how they know exactly when to press an advantage and when to hold back and wait for a better opening. Every generation of orcas inherits the raw ability to hunt, and alongside it, a specific, hard-won memory of exactly how a hunt like this one has succeeded before, refined slightly further with each new attempt. By the time a young orca is old enough to take part in something as dangerous as the coordinated attacks described throughout this story, it has already absorbed years of accumulated technique from watching trusted adults, primarily its own mother, apply that same technique successfully over and over against smaller and safer targets first, long before ever facing anything as large as the sperm whale directly. Instinct alone could never account for a hunting strategy this specific, this coordinated, and this consistently repeated across unrelated pods, separated by thousands of miles of open ocean. This raises a striking possibility about the entire rivalry examined throughout this story. Sperm whales are not simply facing a predator equipped with natural weapons and raw strength alone. They are facing the product of an entire educational system, refined family by family, mother by mother, across generations of orcas who learned, tested, and perfected exactly how to overcome one of the largest and most formidable animals in the ocean. Step back far enough from any single encounter, and a different picture starts to take shape, one written across millions of years rather than a single afternoon at sea. Sperm whales and killer whales did not simply happen to end up facing each other in the ocean by pure coincidence. Both species evolved, generation after generation, at least partly in response to the pressure the other one applied, each shaping the other's size, behavior, and defenses over an enormous stretch of time. A sperm whale's raw size, one of the largest a toothed predator has ever reached on this planet, likely developed for several overlapping reasons, including access to deep-sea squid found nowhere else and no other predator can reliably reach. But that size also happens to provide serious protection against exactly the kind of predator a killer whale represents. An animal capable of crushing giant squid beaks in total darkness is, almost as a side effect, equally capable of seriously injuring or killing an attacking orca with the same jaw or the same enormous tail, a byproduct of biology built for an entirely different purpose. Killer whales, in turn, did not simply grow strong enough to overpower that defense directly through size alone, the way a larger predator on land might simply outmuscle a smaller one. An entirely different set of adaptations developed instead, ones built around intelligence, coordination, and patience rather than sheer physical power. A killer whale pod capable of executing a wound and withdraw strategy across 4 full hours represents a completely different evolutionary answer to the same basic problem, one built on brainpower and teamwork rather than brute force. The result is something close to a genuine standoff, an evolutionary stalemate where neither species holds a clear, overwhelming advantage over the other for very long. Sperm whales remain far too large and far too dangerous for casual, opportunistic attacks. Killer whales remain far too intelligent and far too coordinated to be dismissed as harmless. Every documented encounter throughout this story, whether it ended in a successful defense or successful hunt, represents one small data point in a balance that has likely been shifting back and forth for an extraordinarily long time. Neither predator ever fully wins this negotiation, and neither one ever fully backs down from it either, a balance that has likely held steady, with only small shifts either way, for far longer than either species could ever remember. This kind of standoff shows up elsewhere in nature too, wherever two capable predators end up competing for some of the same resources without one side ever fully eliminating the other. Lions and hyenas across the African savanna share a similarly tense, unresolved relationship, each capable of killing the other under the right circumstances, neither one able to fully dominate the other over the long run. What makes the relationship between sperm whales and killer whales especially striking, though, is just how rarely it actually escalates into open conflict, given how often these two species likely cross paths across the world's oceans over the course of any given year. That rarity itself may be the clearest evidence of just how well matched and how mutually wary these two remarkable predators have become across countless generations of contact. Intelligence in the ocean rarely looks the way people expect it to. There's no obvious tool used to point to, no visible construction of anything resembling a nest or a den, nothing that immediately registers as clever the way a chimpanzee using a stick might to a casual observer watching from a distance. And yet, examined closely, this entire rivalry reads almost like a chess match played out in slow motion across open water, each side adjusting its strategy in response to what the other one does. Killer whales demonstrate their intelligence through planning and patience, qualities easy to overlook in an animal most people associate primarily with speed and raw power rather than careful, deliberate thought. A pod capable of studying a target from a distance, choosing when to strike and when to hold back, adjusting tactics across a 4-hour encounter, and passing all of that specific knowledge down carefully from one generation to the next, is displaying a level of strategic thinking that would be considered remarkable in almost any animal on land. Sperm whales answer that intelligence with a different but equally impressive kind of problem solving built for an entirely different set of circumstances. A marguerite formation is not a simple reflex. It requires dozens of individual whales to recognize danger, coordinate their positioning relative to each other, and maintain that coordination under extreme physical stress for hours at a time. The discovery of defensive defecation at Bremer Bay reveals something even more striking. A group of exhausted, cornered animals improvising a genuinely creative solution, using nothing but their own bodies, under exactly the kind of pressure that tends to reveal what an animal is truly capable of. Neither species solved this rivalry through pure aggression or pure size advantage alone. Both arrived at solutions built on cooperation, communication, and the ability to learn from and adapt to a threat that never behaves quite the same way twice. That kind of flexibility, responding differently depending on the specific situation, rather than following one fixed, hardwired reaction every single time regardless of circumstance, is often considered one of the clearest signs of genuine intelligence in any animal, human or otherwise. This entire rivalry also hints at something larger about the ocean as a whole, a world still full of unanswered questions even after decades of dedicated study. Two of its most capable, most intelligent inhabitants have spent an unknown number of generations locked in this same careful, high-stakes negotiation, adjusting and readjusting their behavior around each other far from any human observer, most of the time completely unnoticed. Every documented encounter examined throughout this story represents one of the rare moments that negotiation happened to unfold somewhere a camera, a boat, or a research tag happened to be present to record it. What that leaves unanswered is almost more interesting than what has already been confirmed. If encounters this dramatic, this strategic, and this rare have only recently started being properly documented, it raises an obvious question about everything happening in the vast majority of the ocean nobody has ever managed to watch closely at all. In every stretch of open water still far beyond the reach of a boat, a drone, or a research tag, for every documented attack that ended with a kill, there appears to be at least one, and likely many more, that ended with the orcas simply giving up and swimming away without any prey to show for their effort or the time already invested in the chase. That detail rarely gets the same attention as the successful hunt, but it may be just as important for understanding how this entire rivalry actually works day to day, far from any camera. At Bremer Bay, the retreat came suddenly, following the disorienting cloud released and spread by the exhausted sperm whales under attack after more than an hour of relentless pressure. One moment the orcas were pressing forward with clear purpose. The next, they were pulling back, eventually abandoning the chase entirely after more than an hour of committed effort. That kind of sudden reversal suggests killer whales are constantly reassessing risk throughout an attack, rather than simply committing blindly once a hunt has already begun and momentum has built up on their side. Other documented encounters, though less dramatic, follow a similar underlying pattern seen again and again across different oceans and different pods. Researchers studying sperm whale populations in various parts of the world have described orcas approaching a group, testing its defenses briefly, and then losing interest entirely once the formation proves too tight or too well defended to offer any realistic opening worth the risk involved. These moments almost never make headlines the way a successful filmed attack does, but marine biologists who study this rivalry closely consider them just as valuable, sometimes even more valuable, for understanding exactly where a killer whale draws the line between a fight worth finishing and one worth abandoning entirely partway through. This constant reassessment reveals something important about how killer whales actually calculate risk during a hunt already well underway, and far from a guaranteed outcome, weighing what has already been spent against what still might be gained by continuing. Rather than measuring success purely by whether an attack ultimately succeeds or fails, a pod appears to weigh the ongoing cost in time, energy, and physical danger against the shrinking likelihood of success as a hunt continues without a clear opening ever appearing. Once that balance tips too far in the wrong direction, walking away becomes the smarter choice, even after a significant investment of time and effort has already gone into the chase. For sperm whales, this pattern offers something close to hope buried inside an otherwise dangerous story. A reminder that this rivalry is not always as one-sided as any single encounter might suggest. Survival does not always require winning outright or overpowering an attacker directly through force. Sometimes it simply requires holding on, staying disciplined, and making the entire encounter costly and uncertain enough for long enough that the predator itself decides the fight is no longer worth finishing after all. Every single encounter examined throughout this story, whether it ended in tragedy or in retreat, adds to a much larger ongoing record that researchers are still working to fully understand. A record that stretches back decades and continues to grow with every new sighting reported from oceans around the world, each one adding another small piece to a puzzle far from finished. Look across every encounter covered throughout this story, from the 4-hour standoff off California to the sudden retreat at Bremer Bay to the small coordinated hunt off Honduras, and a clear trend emerges from the timeline alone. Nearly all of the most detailed, well-documented sightings have happened within the last few decades, and a striking number of them have occurred within just the past several years alone, a pace that shows no sign of slowing down. Part of this comes down to simple improvements in technology now available to ordinary people, well beyond the professional research teams that once held a near monopoly on this kind of footage. Drones capable of hovering safely above a hunt, high-resolution cameras carried aboard tour boats, and underwater tags able to record depth, movement, and sound for hours at a time have all become dramatically more accessible in recent years. Encounters that once would have been witnessed briefly, if at all, by a single passing ship now stand a real chance of being recorded clearly, from multiple angles, by people specifically out on the water looking for exactly this kind of wildlife activity. Better tools alone, though, cannot fully explain everything researchers have observed across such a short window of time. Warming ocean temperatures are gradually shifting where certain prey species, and the predators that follow them, choose to spend their time throughout the year. Some scientists studying killer whale movement patterns believe these shifts may be bringing mammal hunting orca populations into more frequent contact with sperm whales than in past decades, particularly in regions where both species are increasingly drawn to the same productive, food-rich waters. Conservation status adds another layer to this unfolding story, one that extends well beyond the rivalry examined throughout this account. Sperm whales, though recovering steadily since the end of large-scale commercial whaling decades ago, remain listed as vulnerable by international conservation groups, their numbers still far below what researchers believe existed before whaling began in earnest centuries ago and stripped entire populations from oceans around the world. Killer whale populations, meanwhile, vary enormously depending on region, with some groups thriving while others, particularly certain specialized mammal hunting populations, remain critically small and vulnerable to disruption from noise, pollution, and shrinking prey supplies alike. What happens next for both species likely depends on factors far beyond this single rivalry alone, from continued ocean warming to shipping traffic to the availability of the smaller prey both predators ultimately rely on to survive. But the growing record of documented encounters, expanding with nearly every passing year, and drawing on tools nobody had access to even a decade ago, offers something increasingly rare in ocean science: a genuinely detailed close-up look at how two of the most intelligent, most capable predators on the entire planet continue adjusting generation after generation to a rivalry that shows no real sign of resolving in either direction anytime soon. Somewhere out there, right now, in water far from any boat, camera, or research tag, this exact same standoff is almost certainly playing out again, unseen and unrecorded, the way it likely has for millions of years, long before anyone ever thought to watch, and long after this particular telling of the story finally comes to its end.